Going to go through the P4 atomic structure mid-topic assessment now. We're going to be looking at atomic structure, alpha, beta, gamma, also history of atomic structure 2. Question 1. Atoms contain 3 types of particle. Draw a ring around the correct answer to complete the sentence. The particles in the nucleus of the atom are, first option, electrons and neutrons, electrons and protons, or neutrons and protons. Use the picture clue to help you with this one. B. Complete the table to show the relative charges of the atomic particles. Particle charge, relative charge, so electrons have a -1 charge. What charge do neutrons have and what charge do protons have? Again, the diagram might help you here. C. A neutral atom has no overall charge. Explain this in terms of its particles. So you're kind of thinking about that table you've just filled in. What's going on with those positive, negative, neutral charges? That would mean there is no overall charge. Here we've got to fill in the sentence. An atom that loses an electron is called an what? And has an overall something charge. So I've done an example here of lithium losing an electron. What can you say about what it's now called and its charge? Part D. In this question, you will be assessed on using good English, organising information clearly and using specialist terms where appropriate. Some substances are radioactive. They may emit alpha or beta particles. Describe the characteristics of alpha particles and beta particles in terms of their structure, penetration through air and other materials, and deflection in an electron field. So they're not actually interested in gamma in this question, they are just focused on alpha and beta. And if you're in my class, you'll have done a beautiful table which contains details on structure, ability to penetrate through the air and other materials also, so do dig that out to help you. But I've also put some diagrams up on here which should hopefully prompt your memory. We haven't particularly looked at deflection and electron fields, but having a think about the charge of those particles, what they might be, what they're made of, may help you think about what they're attracted to or repelled by, and that diagram there with the negative and positive plates will give you big clues on that one. Question 2. The detector and counter are used in an experiment to show that a radioactive source gives out alpha and beta radiation only. 2 different types of absorbers are placed one at a time between the detector and the source. For each absorber, a count is taken over 10 minutes and the average number of counts per second worked out. The results are shown in the table. So looking at this table, when no absorber was used, there was an average count of 33 per second. When they used 1 mm thick card, that count dropped down to 20 counts per second. And when they used a relatively thin 3 mm thick piece of metal, there was only a count of 2 per second. You're then asked to explain how these results show that alpha and beta radiation is given out, but gamma radiation is not being given out. So how might those results give you a clue? Question 3. The plum pudding model of the atom was used by scientists in the early part of the 20th century to explain atomic structure. And we've got a diagram here which shows that big positive pudding ball which has got the negative electrons dotted randomly throughout. So part A. Those scientists knew that atoms contained electrons and that the electrons had a negative charge. They also knew that the atom was electrically neutral overall. What did this allow scientists to deduce about the pudding part of the atom? I may have already given that bit away there, but have a think and write down your ideas. 3B. An experiment designed to investigate the plum pudding model involved firing alpha particles at thin gold foil. If the plum pudding model was correct, then most of the alpha particles would go straight through the gold foil. A few would be deflected by less than 4 degrees. The results of the experiment were unexpected. Although most of the alpha particles did go straight through the gold foil, about 1 in every 8,000 was deflected by more than 90 degrees. Why did this experiment lead to a new model of the atom called the nuclear model, replacing the plum pudding model? So think about what they were expecting and what they got. So some were deflected a little bit, some were deflected dramatically. Why might that be? But most of them got through. So, looking at this a bit more, the diagram shows the paths A, B and C of 3 alpha particles. The total number of alpha particles deflected through each angle is also given. So we've got a gold foil in the middle there. So A, there is 0 degree deflection. That means they just pass straight through that gold foil. Don't encounter anything. And we can see that 130,000 alpha particles get through with no deflection. That means they're not bumping into anything. B, we can see they've got a 30 degree deflection, so they've moved quite a bit, and that affects about 80,000 particles. And then we've got 30 alpha particles which have been deflected by 150 degrees, so a really dramatic turnaround there, big change in angle. Using the nuclear model of the atom, so think about how our atom is structured now. How does that explain these 3 pathways? Now, using the nuclear model, the scientist E. Rutherford devised an equation to predict the proportion of alpha particles that would be deflected through various angles. The results of the experiment were the same as the predictions made by Rutherford. What was the importance of the experimental results and the predictions being the same? So, Rutherford predicted something and it was backed up with data. Why is that important or significant?